Hi, I'm going to do assignment 4, which is require us to apply an ideal bandpass filter on the wavefile recorded in assignment 2, which is my name is Sophia. Okay, so first we have to use FFT to obtain the frequency signal, which is here. I'm going to do I have write these codes earlier, so I just copy and paste. So this is the location of the audio. Okay, so this is the number of samples and the frequency and so on. So this is to perform an FFT. So first I just plot the original signal. Okay, so this is the original signal, which is this audio.
My name is Sophia.
Okay, so this is the original signal. Then the FFT signal is this one. Okay, so as you can see, we perform FFT so that it can be filtered later on. Alright, so next we have to apply an ideal bandpass filter to remove all the frequency outside the usable voice frequency. Means for this case, we use frequency between 300 to 300 Hz. So we cannot perform the Boolean function. So we have to create just a simple square wave represent as the bandpass filter. So here, this is the bandpass filter codes. So as you can see, there is no Boolean function there. Okay, so I'm going to plot the filter. Okay, so as you can see, this is the ideal bandpass filter, which ranges from 300 to 3000 Hz. Alright. Okay, so we want to filter the original signal. So what I'm going to do, since we cannot perform the Boolean function, so I manually multiply the original signal and the bandpass filter signal. You just times the two and you will get this graph. Alright. Okay, so this is the filtered audio signal. As you can see, just now the signal is from 300 to 3000. So yeah, this is the filtered signal. Then the last task, we have to perform an inverse transform of the filtered signal, which we have to perform inverse fast Fourier transform. So to perform inverse Fourier transform, we just use IFFT. Okay, so basically this is the signal, the inverse Fourier transform. So as you can see, there is no difference in sample frequency between the inverse Fourier transform and the original and the original signal. Sorry. There. What's the difference between the original and the inverse Fourier transform is only the amplitude. As you can see, this amplitude, the original is somewhere between 0.8. Then the inverse is from 0.4. So it reduces. So this when we perform the ideal filter, we can hear the ringing effect. So just to give you the idea, so this is the ringing effect. This ringing effect occurs because this is the drawback of this ideal filter, because it occurs when you apply the ideal filter. So that's all for me. Thank you.